Okay, I'm going to be teaching you about mixture equations. And this is a good example of where algebra can start being helpful in the real world. If you're going to grow up and be a scientist dealing with chemistry, you'll be doing this kind of stuff all the time. But the mixture equation is this. The percentage of the first times, that should be plus, the percentage of the first plus the percentage of the second equals the percentage of the first plus the second. And I believe in your notes you might want to check that. Make sure that says mixture there. It might say something else. That was a typo. Another teacher wrote this for me. But that should be a plus sign there. All right. Percent of the first plus the percent of the second equals the percentage of the first plus the second. Pretty easy formula. So when you do a mixture problem, all you have to do is just fill in the blanks. All right. So the percent of the first. So let's read this. So I have 90 milliliters of 25% acid. How much water needs to be added to make a solution with 10% acid? All right, well that sounds pretty complicated, right? But let's just break it down. So we're dealing with acid here. So what percent is the first acid? Well, it's 25%. So 0.25 of the first, how much is in the first? The percent of the first, how much is in the first? Not 50. So 0.25 times 50 plus how much water needs to be added. Now, this is where we're going to have to think for a few minutes. If I add water to this, how much acid is in pure water? You might be thinking that's a trick question, and I guess in a sense it is. But water is 0% acid. And pure acid is 100% acid. So when they say they're adding water, what they're basically saying is they're adding a mixture that has no acid in it. And when they say they're adding pure acid, they're basically adding a mixture that is 100% acid. All right? So we're adding water to this. All right? Well, what percent of that water is acid? Well, 0% of the water. How much water? I don't know. Let's call it W. Right? 0% of W should equal the percentage of the first, there's the percentage of the first, plus the percentage of the second, there's the percentage of the second, equals the percentage, 10%, so 0.1, of the first, 50, plus the second, W. Get it? So all we have to do then there is just do the math. So 0 times W is gone, so I have 0.25 times 50, and 0.25 times 50 is, by my calculations, 12.5. So this is 12.5 equals 0.1 times 50 is 5 plus 0.1 times W is 0.1 W. Now right here, if I want to, I can get rid of the decimals by multiplying everything by 10. I'm going to go ahead and do that. Multiply this by 10, multiply this by 10, and I'm left with 125 equals 5 plus W. Then all I do is subtract 5 from both sides or add -5 to both sides, and that makes 120 equals W. What the heck does that mean? I did all that algebra. What this means is if I take a mixture that's 50 milliliters of 25% acid, so a mixture that's 25% acid, and I mix 50 milliliters of that with 120 milliliters of water, I will make a mixture that is 10% acid. That's what I'm saying there. Okay? So let's do another example. If you add 15 milliliters of water to 75 milliliters of 40% acid, what percent of acid is in the new solution? All right, well, let's go through the same thing again. Remember what the formula says. Percent of the first plus the percent of the second equals the percent of the first plus the second. All right, so let's just fill in the blanks. Percent of the first. Well, the first one is 15 milliliters of water. And as we said earlier, let's go back up here and look at this. Water is 0% acid. So in my first one, I get 0 times how much water? 15 plus 0.4 times 75 equals the percent of the total. Well, I'm trying to solve for the percentage, so that's x times the first. How much was in the first? 15 milliliters. Plus, how much was in the second? 75 milliliters. So I end up with 15 plus 75 is 90. I end up with 90x equaling 0 times 15 is 0, so this is gone, and I'm left with 0.4 times 75, and let's see, that's 15, that's 30, I believe. So divide both sides by 90, and I get x is 1/3, which if you know what that means as a percentage, 1/3 is 33 and 1/3%. What does that mean? That means if I mixed 15 milliliters of water with 75 milliliters of 40% acid, I would make a new mixture that is 33 1/3 acid. Okay? Let's do another one. All right, we're going to go ahead and skip number 3 because, like I said, that's a typo. Found a couple of them in this lesson. I have to fix that on the actual notes, but let's do the fourth one here, which is the last one. All right. How many ounces of acid should you add to 200 ounces of 50% acid to make a solution that's 75%? And that should say 75% acid. Okay. All right. This one's complicated, but let's go through the problem again. Percent of the first plus the percent of the second equals the percent of the first plus the second. Okay? So let's go through it. How many ounces of acid, all right? And when I say acid, I mean pure acid. So how many ounces of pure acid should I add to 200 ounces of 50% acid to make a 75% mixture? All right, so let's go through it. What percent, if I add pure acid, that's 100%, which is 1. 1 times, how much of that am I adding? I don't know. Let's call it X. You could call it A for acid too. Plus, what percent is the next acid? Well, it's 50%, so it's 0.5 times what? 200 equals 0.75 of how much is in the first? I don't know. Let's call it X. How much is in the second? 200. And I end up with this equation, right? Well, 1 times X is X, so I get X plus 0.5 times 20 is half of 20, sorry, 0.5 of 200 is 100 equals 0.75 of X is 0.75X. And 3/4 of 200 is 150. All right. In this case, I probably won't multiply this by 100 to get rid of the decimal because I end up with some ugly bigger numbers. So I'm just going to do the math with it. I'm going to subtract 0.75x from both sides. Really, I should be saying adding a negative 0.75x to both sides. So I'm going to add a negative 0.75x to this side too. If I have 1x minus 0.75x, I have 0.25x plus 100 equals 150. Subtract 100 from both sides. By now, you're probably getting pretty good at algebra, but I'm going to still go through it with you. Right here, 150 minus the 100 is, sorry for the scribble there, 150 minus the 100 was 50. And 0.25x x equals 50, so now I had to divide by 0.25, divide by 0.25, and if you know any math here, when you're dividing by 0.25, you're dividing by 1/4, which is the same as multiplying by 4, so you get 200. So what am I saying here? Well, what I'm saying is, if I add 200 milliliters of pure acid to 200 milliliters of 50% acid, I will make a mixture that's 75% acid. Well, that's logical, right? You add half and half, it's going to be halfway between them. So there you have it, the mixture questions dealing with percentages, and it's probably the first good example of using algebra in real world. I'll tell you what, a lot of people are really bad at these. When you get to chemistry someday, you may have to come back and thank me for teaching you this, because this is a very easy way to do these types of problems. All right? Good luck and have fun with it.